Hi everyone, today we're going to be doing lesson 6-4. Our objective is to write and solve system equations from real world situations. I have had a plethora of errors trying to record this video with things shutting down, having problems, and it's kind of long. Therefore, I'm going to break this into two separate videos, first covering the first 3 example problems and the second video doing the last 3 example problems. Our goal today is determine the two quantities involved in the situation, assign variables, and write a linear equation for both, and then solve in using any of the 3 methods. You can decide which method you prefer. You can use any of the 3 methods, but some are better than others depending on the situation. So let's look at our first example. It says we have a rectangular driveway that has a perimeter that is 278 feet. Now remember, the perimeter is the distance around. So I have my rectangular driveway right here, and it says my perimeter is 278. Well, let's think about perimeter. I have my length, and I have my width. So those are the variables I'm going to use. I'm going to use L for length. I usually do an uppercase L when I use an L for a variable, only because L's and 1's can look a lot alike. So L and W for my variables. So my distance round would be my length plus my length, which would be 2L, plus my width plus my width, so 2 widths. And it tells me that my perimeter is 278 feet. What it also tells me is my length, L, means equals 35 feet longer than, that sounds like adding to me, my width. Now we said the length of my width, the measure of my width is going to be W. So L equals 35 plus W. Because I like to write things in slope-intercept form, I'm going to put W plus 35. So my length is equal to 35. I just said I was going to put my W first, and then I didn't. W plus 35. Well, let's look at our options over here. I have length plus 35 equals W. Well, no, it's W plus 35 equals length, so that doesn't work. This one says length equals W plus 35. That works. And 2L plus 2W equals 278. That looks good. Let's look at the other ones just to make sure, though. Length equals W plus 35. That one's good. But length plus width does not equal 278. Length plus width is only halfway around my rectangle. My last one, L equals W plus 35. That's fine. LW, that means L times W equals 278. Well, that would give me area, not perimeter. So that one doesn't work also. So now we want to think of which method is best for solving this. Whenever I see that L equals, or X equals or Y equals, whatever, I start thinking substitution. Substitution. So if my L equals W plus 35, that means I can package that up and I can put it right here where L is in the other equation. A lot of misspeaking today, I'm sorry. So if L equals W plus 35, wherever L shows up, I can put W plus 35. So now let's rewrite our equation. 2 times W plus 35 that package right there, plus 2W equals 278. My next step will be to distribute 2 times W and 2 times 35. 2 times W is 2W plus 2 times 35 is 70. I think I said 2 plus 35, 2 times 35. 70 plus 2W equals 278. Now I'm going to combine my like terms. So you can see I have a 2W plus a 2W. So that will give me 4W plus 70 equals 278. Now I have a simple two-step equation. First step, let's subtract 70 from both sides. And I have 4W equals 208. And my last step will be divide both sides by 4. And my width, or W, will equal 52. W is going to be 52 feet. Now my length, we know my length equals W plus 35. Now that I know my W is 52, my length will be 52 plus 35. So my length will be 87. Feet. Now if I added up all of my sides, 87 plus 87 is 174. 52 plus 52 is 104. 174 plus 104 hopefully equals 278. And it does, which means my problem works. My width is, my width plus 35 equals my length, and my whole perimeter is 278. Let's look at my next example. This one, it says the cost of a group of 6 adults and 4 children is $195 for tickets to the Monster Jam. And a group of 2 adults and 3 children will cost $90. So we want to write and solve our system of equations to find the cost of an adult and the cost of a child ticket. So our variables are going to represent our costs. I'm going to put A for adult ticket and C for the cost of a child ticket. It says here that 6 adult tickets and 4 child tickets cost a total of $195. It also tells me that 2 adult tickets and 3 child tickets cost a total of $90. So when I see that I have two equations that are both written in standard form, I immediately start thinking of elimination for my method of solving. Now, nothing cancels out. I have 6a here, I have 2a here, I have 4c here, I have 3c here. Nothing's going to cancel out. So I'm going to have to change one or both of my equations. Well, when I see this 2a and 6a, I go, oh, I could multiply this whole thing by -3, and then my a's will cancel out. So that's what I'm going to do. I could have done something else, but I kind of like this. We'll multiply this by -3. So -3 times 2a is -6a. -3 times 3c is -9c. And -3 times 90 is -270. Now I can add these two equations together, and I will get my c by itself. So this cancels out. 4c plus -9c will give me -5c. So now I have a single variable equation. 195 plus -270 is -75. Next step, I'm going to divide both sides by -5. And the cost of my child ticket will be -75 divided by -5, or $15. Each child ticket will be $15. Now I have to figure out the cost of my adult ticket. I could use either of these equations to figure it out. I always use my original equations, not after I've multiplied that by -3. So I could use this one, or I could use this one. Let's use this one. 6 adult tickets plus 4 child tickets, and each child ticket is $15. Equals $195. I should have given myself a little more room. 4 times 15 is 60. 6 adult tickets plus 60 will equal $195. Let's subtract 60 from both sides. Then I'm going to move over a little bit to give myself a little more working space. So I have 6 adult tickets will equal 135. Divide both sides by 6. And each adult ticket will be $22.50. I'm going to go to 2 decimal points because I am talking money. So each adult ticket will be $22.50. It's not a bad idea to go back to your original problem and see if the other problem, since I use this one to solve it, go to this one. Well, 2 times $22.50 is $45. Plus 3 child tickets at $15 each. 3 times 15 is 45. Does 45 plus 45 equal 90? It absolutely does. So just doing a quick check can verify that I have the correct price for both of the tickets. Let's look at my next example. This one you might think is very similar to the last one, but last time we were looking for the cost of each ticket. This time we're looking for the number of tickets sold. It said the RHS play costs $6 for an adult and $4.50 for a student ticket. So we're going to call our variables. A is our number. We're going to use what you know as the hashtag, but that's actually a number symbol. Number of adult tickets. Now, my next thing is student tickets. I'm going to tell you I will rarely use S for a variable. And that's because if you've seen my handwriting, my S's and my 5's look an awful lot alike. So I apologize to those of you who do not think students are children, but I'm putting a C instead of an S for child tickets versus adult tickets. You can think of it as student, but I just know that S's and 5's look way too much alike. I'm going to use a C. So what do we know about our number of tickets? Well, we know that if we have both our adult and our student tickets added together, it's 127 tickets. So adult plus child tickets, the number of each, has to equal $127. Not 127 tickets, not dollars. We also know that each adult ticket is $6. So I can do 6 times the number of adult tickets. Will tell me the total amount of money that we made selling adult tickets. And 450 times the number of child tickets sold will give us our total cost of our child tickets. And together, the value of that is $699. Again, I can think about what's the best way to do this. They are written in standard form, so my inclination is to use elimination. To eliminate, I could try to eliminate my A's, or I could try to eliminate my C's. I forgot to write my C here. I better write that in, 450 times C. Just because it's easier to multiply by 6, I'm going to multiply both the top and bottom by -6. So -6 times A is -6A. -6 times C is -6C. And -6 times 127 is some number that I don't know off the top of my head. So I'm going to do my math pretty quick. 127 times 6 will give me 762. So -762. Let me add these two together. And my A's cancel out, leaving me with a single variable equation. And 4.5 minus 6 is -1.5C. And 699 minus 762 is -63. Let's divide both sides by -1.5. And I believe it is 42, but I am going to verify that. -163 divided by -1.5. That was not correct. 63 divided by 1.5. I think I did 163 for some reason. I went through all that. It took way too long to find out, yes, it is 42. So that actually answers my questions. How many student tickets were sold? It was 42. But let's just verify other stuff. If I sold 42 children tickets, I know that my adult tickets plus my child tickets or my student tickets, which is 42. I almost didn't substitute that. Has to equal 127. So to figure out how many adult tickets I sold, it would be 45 adult tickets. 85. Did I say 45? I'm having trouble with misspeaking today. 85. So 85 adult. Now let's think what this is worth. Each adult ticket is $6. So 85 times 6 is $510. Each student ticket is $4.50. So $4.50 times 42 tickets is $189. And if I add that together, I should have $699 for 127 tickets. And I do. Always good to check. I'm going to stop my video here, and I will continue on my next video just to make sure that we don't run into any technical difficulties because it's a pretty long video. See you soon.